All right, so now I'm going to look at probability trees, but with questions that involve reduced sample space. Um, so first, this question was on Education Perfect, um, and it was on the task called Reduced Sample Space Probability Trees. So here, um, Rowan has an 88% chance of passing a university exam if he attends all lectures. If he doesn't attend all lectures, he has a 45% of chance of passing, and there is a 0.72 likelihood that he will attend all. So the first thing I'm thinking is that there are two events happening. Um, the first event is that Rowan attends a lecture because he's going to have to attend the lecture before sitting the exam and passing. So our first event is that Rowan attends or doesn't attend. So maybe I'll go down a little bit actually. So there are two possibilities here. Rowan attends or Rowan does not attend, and that little line there means not. So attends and doesn't attend, and that's attending his lectures. And then we have the second event, which is the chance that Rowan is passing or failing or not passing, and that happens whether or not he attends or not. So this is the possible probability that he will attend and then passing, attend and not passing, not attend, passing, not attend and not passing. So we've drawn up the scenario in a probability tree, and all we have to do is go to across to find out the probabilities of what's happening. So let's start filling it out. Rowan has an 88% chance of passing a university exam. All right, so what we have to do now is write up the probabilities. So he has an 88% chance of passing if he attends all lectures. So he attends and he passes. So this is the probability. So 88% chance. The chance is 88% chance of passing if he attends. So if we have that if, the joining words in probability questions are important. So if he attends, so it goes here. It's not saying the probability that he attends and he passes. Otherwise, that would be right at the end here. It's saying if he was to attend, what's the probability of him passing? It has not happened yet. We're just calculating the probability. So that's what it means by a reduced sample space. The probability of him passing out of the probability of him attending. Okay. So let's fill it out. So now we know that's 0.88, so this must be 0.12. Let's see what else we have. If he doesn't attend all lectures, he has a 45% chance of passing. So he doesn't attend, 0.45 chance of passing. All right, and then that's the same thing here. These have to add up to 1, so that's 0.55 chance of not passing. There is a 0.72 likelihood that he will attend all lectures, and that just goes, oh, sorry, 0.72. So 1 minus 0.72 to get this probability here, 0.28, and we filled out all the probabilities. So here the probability of attending and passing is 0.72 times 0.88 is 0.6336. 0.72 times 0.12 is, so that's the probability of attending and not passing, is 0.0864. The probability of not attending and passing is 0.28 times 0.45, and that is 0.126. And finally, the probability of not attending and not passing is 0.28 times 0.55, which is 0.154. All right. So if we want to start answering this one, find the probability that he attended all lectures and passed the exam. So this is and probability, okay? So we multiply across, which we've already done. These are all and probabilities here, these ones. Probability and we've already found them. So it's quite easy to figure out now. Find the probability that he attended all lectures. So I'm going to start highlighting across to show you. He attended all lectures, and the probability and that he passed the exam. So it is 0.72 times 0.88, and we've already done that calculation. 0.72 times 0.88 is equal to 0.6336. So we have just found that probability quite easily. Let's keep going. Find the probability that he passes the exam. This is a little bit different. So we want the probability that he passes. So let me highlight all the and probabilities of him actually passing. Oops. Oh well. Okay. So let's highlight. There's a probability that he attends and he passes. So that is him actually passing. So I'm going to tick that. Then there's a probability that he doesn't attend the lectures, but he still passes. So that is this probability. So what we do for OR probabilities, when we go down, okay, OR probabilities are added, and probabilities are multiplied. So let me write that down here. And probabilities, OR is adding. Okay. So 0.6336, 0.6336 plus 0.126. And let's see what that is. 0.6336 plus 0.126 is 0.7596. All right. And here is the final question, which is a given probability, which means it needs a reduced sample space. Find the probability that he attended all lectures given he passed an exam. So the way we write these probabilities is probability that so the one we want to calculate goes first in our abbreviation here. So probability that he attended all lectures, given, that line means given. So the way you read it, find the probability that he attended all lectures given that he passed an exam. Okay. So in a normal theoretical probability, the way we'd calculate probability is the probability of an event happening, the probability of the thing we want to happen. Sorry about the handwriting, and that's over the total. When we have a reduced sample space, our total is changing. So if they asked what's the probability that he just attends lectures, just like he did before, so the probability that he attends lectures, we write the probability of him attending lectures here out of the total probability, okay? Because they're not telling us anything else. It's just out of the total. But in this case, in a given, what they're actually saying is, what's the probability that he attended lectures out of the probability that he has passed the exam. So that's what this is trying to say. Whenever you see given, it's trying to say that, well, I want to find out the probability out of the total that he passed the exams. All right, and we can use the probability. So what's actually changing here? Sorry. Probability of the reduced total, because our total has reduced from everyone, from anything that he did, whether he passed or failed, to just passing. Our total has changed to just passing. So when we look at the probability tree, what we actually want is the probability of him attending all lectures and passing, which we already calculated right here, over the probability of him passing at all, which is the probability that we found right here. Okay, so that's the probability of him passing. This is the probability of him attending all lectures and passing. All right. So we have to put the probability of him, the reduced total, passing in the bottom. The probability that we want to find out is that he actually attends all lectures and he passes. Okay? So if I look back at my probability tree, which we don't really need to, we've already calculated everything we need here, but I just want to show you. So what we're putting right on top is the probability, so maybe let's change the highlighter. The probability that he attends and he passes, so it's this probability again. And then we want the probability that he passes, which is, again, this probability, and we add them together. Oftentimes, when you're asked for a conditional or a given, the reduced sample space is going to be two and probabilities added together. Okay, so let's do that. And I'll do it the long way, even though we've already done it here. So the probability of him passing and attending is 0.72 times 0.88. And then it's the probability of him passing the exam. So the first scenario is this one right here, the same as before, 0.72 times 0.88 plus the probability he attends and he passes, so 0.28 times 0.45. 0.28 times 0.45. Okay, this is just a long way of doing it. You can skip all this. 0.6336 over 0.7596. We put that in 0.6336 divided by 0.7596 is 0.834, and let's do 3 dp. So 0.8341 is the probability that he attends all lectures given that he passed the exam.